Previously on Lost.
No! What the f? Oh my god. The previous episode in this 1986 GPZ project series kinda ended on a cliffhanger. I'm not gonna name any names, but someone did some pretty severe damage. Before that point though, every single hydraulic system on the bike was completely overhauled. Both the front and rear brake master cylinders, the rear caliper, and the front two, as well as the master and slave cylinders for the clutch system. Consolidated Motor Spares was kind enough to donate brand new parts to make some of those jobs happen, as well as new seals so I can overhaul the front suspension. And that's where things went south. It's not terribly difficult to rebuild forks on a motorcycle, but if you were to do something like, I don't know, not undo the upper clamping bolts on the triple tree that are squeezing down right on the threads of the caps that you're actively trying to remove with an electric impact driver, then you might have some problems. Can I get a yikes? Yeah, this is bad. But after only an hour of crying, I realized my mistake, loosened up those clamps, and brought out the extractor set. Now, I totally would have shown you guys this damage last episode, but I didn't want to show it without also showing how I'm gonna fix them, and I didn't have a solution until halfway through filming this episode. Thank you, Dad, for the extractor kit. Wish I didn't have to use it though, but I'm glad I got it. Oh, that's really clean. Oh, wow. That is very clean oil, oh my god. Huh, maybe these were recently rebuilt. Oh shit. Good god. There we go. Hell. I really need to stop doing that, huh? After getting the travel control valve out of there, I pulled the parts from the other fork as well, carefully this time, and left these to completely drain. The inner and outer fork tubes are held together by a damper rod that's inside the unit, and that's secured by a little bolt down here. Getting this out can be tricky, especially if the only Allen socket you have in this size is too short to fit and you're forced to go out and buy a larger size, but mainly because when you go to turn the bolt, you end up just spinning the damper rod inside, not actually loosening anything. Kawasaki has a tool meant to hold the damper rod and prevent it from spinning, but I'm not about to drop $40 on something that can be made out of a piece of wood. Online, I found a listing of an OEM one next to a ruler, and derived some rough measurements from that. And after marking up the wood, I went to town with the disc sander. Truthfully, it doesn't have to be too exact, because all that really matters is that it's tapered, and that when you install it, you give it a few good whacks. With a pair of vice grips on there to prevent the dowel from spinning, the bolt should just break free now. Yeah, if you hear that squeaking sound, that's just the wood rotating inside and the bolt actually not coming loose. Okay, maybe I need more power. Okay, yes. Yes! Ha ha ha! You smell that? It smells like old oil. Wait, you can't smell that? You should get your nose checked. The next step for separating the fork tubes, after pulling out the damper rod and spring, is removing the upper dust seal. A tiny screwdriver is employed for that job, being careful to only touch the rubber of the seal and not nick the metal tube. Ooh, that's pretty gross looking already. With it in the vise, I went ahead and cleaned out the rest of the gunk. Gross. And popped off the clip inside. And there's supposed to be a washer there. There's not a washer there. It's just the seal. Are you kidding me right now? I was gonna rebuild these things today. I said that nothing else bad in the bike would surprise me. I narrated that, but I'm still surprised. Okay, I'm gonna just keep moving forward. The last things holding the inner tube in place are that oil seal and the pressed in bushing below it. And getting those out is as simple as giving the shaft a few good yanks, and I've got plenty of experience with that. But now I can dump out the damper rod stop, slide off the oil seal, lower washer, upper bushing, lower bushing, and lastly remove the damper rod washers that were still inside the outer fork tube. The exact same steps were done for the other fork as well. This one also had the exact same issue of not having an upper washer, but more than that, the lower washer that goes between the bushing and oil seal was very deformed. Looking at it next to the one from the first fork, it's not flat. It's subtle, but it is bowl-shaped. There's just been so much negligence on this bike in pretty much every area, so at this point, this is just par for the course. So to start the cleanup process, I want to look at the top of the inner fork tubes where the caps go, because they're a little rusty. Luckily, the right tube is very clean directly at and below where the O-ring for the cap seals against, so that's probably going to be okay, but the left fork is just bad, man. So to clean these up, I went to town with a wire wheel on my drill, specifically a soft brass one. I don't want to mar up what's supposed to be a sealing surface. They definitely look better, but clearly not good enough. I did another round of wire wheeling, but I think it's just polishing the rust more than it is removing it. So for my next course of action, I got some very fine sandpaper doused in WD-40 and went over it ever so lightly. And to my relief, a very faint shiny ring appeared. There's absolutely no pitting, and it seems like it's the exact same height as where the clean section of the other one starts, again, which is where the O-ring sits. So this is probably gonna be okay. But I do still want to get rid of the rest here, but not like this. I have a different idea. I've got a Vaporust, and I got this for actually something later on in this episode, but I might as well go ahead and give it a try now. Unlike acid or mechanical-based methods of rust removal, this stuff is not at all harmful to the base metal, since it operates by a very safe process called chelation. Basically, instead of attacking the rust, it kinda just hugs it for a very, very long time until it gets very uncomfortable and the rust just throws itself overboard. So, no physical damage done, just emotional. And after only 30 minutes, the fork tubes already look immensely better. I popped them back in the Vaporust bath for almost 2 hours this time, gave them one final whirl and wipe down, and wow, rust hoomst? Clearly there's still a lot of pitting, but like I said, not in the sections where the O-rings touch when installed, so this should be a-okay. The only other corrosion happening on these tubes is a few speckles on the outside. That could be a real problem, but luckily it's only on the top half. The travel sections of the tubes that pass over the bushings and seals are spotless, so these are absolutely golden. The only remaining corrosion on the suspension is what's hiding out on the outer fork tubes where the bushings and oil seals go. I started cleaning this up with the brass wire wheel as well, but with the sealing surface being made of aluminum, it kinda gave me the heebie-jeebies. I mean, maybe it's not too aggressive, but instead, I whipped out the WD-40 in red scuff pad. And after applying a little bit of elbow grease, it looked a million times better than how it started. There's some slight discoloration, but it's super smooth, so it's good. And of course, the exact same thing was done for the other one as well. There is still grime on all of the little internal components, so they're going to take a dip in the ultrasonic cleaner. After a little while in there and some rinsing off, these freshly cleaned parts are looking as clean as freshly cleaned parts. The Teflon coating on the outside of this bushing is ever so slightly worn, and the same for the inside of the other one, but overall they're not in terrible condition. These can absolutely be reused. Now you don't always have to replace bushings when doing a fork overhaul because a lot of the times it's just the seals that are bad and these are pretty okay. But on CMS's website, they do not stock replacements for these bushings. On the GPZ Zone website, a part supplier specifically for this family of motorcycles, they do not supply these bushings. And same for eBay when you look at the part numbers and other websites. Gonna have to reuse these. Not ideal, clearly, but they're not in the worst condition, so it's probably gonna be okay. God, I hope so. The very last parts to take care of are the absolutely trashed caps. I went online to find replacements, but what I found instead was a bit of a rabbit hole. What in the heck is this? My bike does not have that. I took a look in the factory service manual and also found it there. Well, these forks are pressurized, or they were pressurized, and apparently this part is a balance tube meant to equalize that pressure between the two forks. But again, my bike does not have that. And it's not like I can just go buy one and add it to the mix either, because when you have a tube that's tied into a system, you also gotta have a hole for that tube. Looking at a used fork on eBay, there's a hole, clear as day, but on my forks, there's no holes. And that's because it's not supposed to have any. I did a lot of digging online, and from what I understand, this balance system was nixed not long after production started, probably due to it being completely unnecessary. Some forks from 1986 have it, and others, like mine, don't. Also, looking a little closer, my manual is a first edition, so of course it wouldn't include the later redesign. I really love getting lost in the history sauce and figuring this stuff out, but unfortunately that doesn't get me any closer to replacing these caps. It turns out, these are discontinued from Kawasaki and no third-party supplier has any new old stock. I spent a month scouring the web for any used ones to pop up for sale, until it finally clicked in my head, why not just go down to my local machine shop to see if I can save the ones I already have? Well, one day later I came back home with these. There was still plenty of meat left on it, so the guys at the shop just machined a smaller hex into it. Going from a 19mm to a 16 might seem like a drastic jump, but the torque spec for this is only 16 foot-pounds, so they should by no means be undersized. I just gotta make sure to leave the triple tree bolts loose. But with this finally fixed, it's time to get these back together. The fork I have laid out here is the one with the deformed lower washer, so that is getting replaced with a brand new one, and I actually want to install an upper washer, like they're supposed to be, so I got a new set of those too. The new seals from CMS replaced the old ones, and lastly, I'm swapping out the old crush washer with a brand new one. I only test my luck reusing those on oil pans. For reassembly, the manual says just do the reverse disassembly, and those instructions are very vague, so I drew up my own diagram and wrote out my own steps just to be sure I wouldn't mess up. Bonus points to anyone that can point out the one part I forgot to draw and label, and I'll tell you right now, it's not the anti-dive unit. Starting off is the damper rod. That guy gets rubber malleted onto the DIY tool, then clamped down in the bench vise. The damper spring goes on next, followed by the inner fork tube after lubing it up with fork oil, as well as the bushing, and snapping that in place. And of course, I didn't clamp the wooden dowel high enough, so I raised that up until the damper rod fully sticks out. Then install the 3 washers, followed by the damper rod stop. The outer fork tube gets a healthy coating of oil, and then it's let over the whole thing. Now, the next step is a little bizarre to me. The manual specifically says to use liquid gaskets on both sides of the crush washer for the lower bolt. I have never heard of that being done on any application of a crush washer, because the washer itself is supposed to be the seal, but hey, if Kawasaki said to do it, I'm gonna do it. After applying some blue thread locker, the bolt was threaded in place until it just started spinning the damper rod. After adding on the vice grips and making sure the tool is snug, the bolt was torqued to spec. For the upper bushing, I set it in place so that the split in it is in line with the axle. To install it, you're normally supposed to use either a specific tool or a long pipe of the same diameter and hammer that down. I don't have either of those, but what I do have is that deformed washer from earlier. With that guy, I can just use a punch to slowly but surely drive the bushing into place. With the washer being the exact diameter, it acts as the perfect buffer to evenly distribute that force. And once it's sitting flush, I can install the new washer that's actually flat. And then the new oil seal. For this guy, I did actually have a PVC coupler that was the right diameter, so I used that and the deformed washer. I got it down just shy of the groove ring, then added the new upper washer and secured that in place. And lastly, I capped everything off with the new dust seal, using the old one to drive it into place. Now, 99% of the time, this is where you would add in the travel control valve, mainspring, fill her up with oil and cap everything off and call it a day. And I was desperately wanting to do that, but that's not gonna happen. I need to do something about the anti-dive unit. Truthfully, I was originally planning on ignoring the system altogether, but it started to eat at me. If the seals on the brakes and the forks were as bad as they were, the ones in here are more than likely garbage as well. Meaning, it's not out of the realm of possibility for this to cause both brake and suspension failure. Typically, you don't want that to happen. You might think it would be simplest to just cap everything off and ignore the system altogether. And you'd be right, but it's not the cheapest. See, the oil in the fork flows back and forth through the anti-dive body unit when the suspension is bouncing around, so adding on a simple cover plate would completely stop that flow, preventing compression from happening, rendering the entire forks useless. So because of that, a custom plate that still allows oil flow would have to be either purchased or custom made. It's more of a headache to fully rebuild this, but it's way cheaper, so that's what I'm gonna do. Kawasaki stopped supporting this component ages ago, but fortunately, the GPZ Zone, who I mentioned earlier, supplies all of the parts to do this job properly. The only thing is that they're based in the UK, not in Texas right by me, so I've gotta wait a couple weeks for the parts to come in. So, in the meantime, how about we take a look at the back of the bike? A complete overhaul back here isn't in the cards, but I do need to replace both tires, so this guy is coming off. Oh, I wasn't recording that? Ugh. Well, I just took off the nut that was there. Why do I do this? But I had a little trouble with that because I couldn't find the master link to take apart the chain. I ended up just walking the wheel off the chain, which is easy enough, but that missing link is a little concerning. Now, like I said, I don't see a master link to remove. There should be a piece that looks like this, but there's not. Wait a minute, is that... Those are raised, like there should be a little master link retainer in there. So these two little nubs are raised out, and there's the slot behind them to put the retaining clip. This is the master link, but it was missing the clip that holds it in place, so I guess rust, grime, and oil have just been preventing the chain from falling apart. So if I would have just tried to run this as it is, there's a very good chance the chain would just falling apart while riding, and that is not ideal. Let me tell you that. Oh, not ideal at all. Well, I say that, but maybe it wasn't all that necessary because it took about 8 minutes of WD-40ing, prying, more prying and hammering to finally get it to come apart. Oh. I'll come back to the chain later because right now, it's bath time. Cleaning your wheels before you bring them down to get new tires fitted is important because one, when they're adding wheel weights to balance the tire, there's a clean surface for them to properly adhere to, and two, so that you're not a dick dropping off filthy parts for techs to work on. And speaking of clean surfaces, the swing arm and surrounding components are absolutely filthy. So while I have the wheels off this thing, looking like a straight up hover bike, I want to go ahead and clean this rear section up. So much junk came off. Yeah, I would say that looks a little bit better. Or maybe a lot better. But with it clean now, I noticed a lot of scraping on the suspension linkage that looks to be from the fender liner. With it right up on it, I'm honestly surprised the plastic wasn't the thing that got scraped away, but regardless, it needs to be adjusted. So with the help of a heat gun, I was able to finagle it to where there's loads of clearance. Perfect. Another issue is with the chain guard. I'm not talking about how absolutely filthy it was, though it did take me ages to remove all of the dirt, grime, and I'm pretty sure fecal matter, at least it tasted that way, but no, I'm talking about how it's bowing out so much and how the little slot on the swing arm that holds it in place is bent way too far down. When it's bolted up, it just does not want to stay in place. That'll definitely rub on the wheel, and it looks like it already has been, but with a little bit of heat and persuasion, and heat, and persuasion, it's good as new. Oh yeah. This thing wants to be in there. Nice. And also, I didn't cause any warpage that could have created clearance issues for the sprocket, so cool. That sprocket and the rest of the subcomponents for both the front and rear wheels were given a thorough cleaning, so they're good to go too, except for the bearing inside the sprocket. It's an open kind, meaning it's accumulated 35 years of crud, gunk, and other contamination. Not to mention, it's pretty loud. So let's get some fresh grease in there. I went to town with brake cleaner, lots of paper towels, and compressed air to remove as much junk as possible. I'm sure using my hydraulic press to remove the bearing would make dealing with all this a heck of a lot easier. It would especially help out for packing it with new grease. But why spend 20 minutes doing that when I can spend 3 hours doing something else? So I made this. No, it is not a scale replica of my left nipple. It is actually a DIY bearing packer, specifically for this bike. Or that's the plan, at least. Let's see if this works. I absolutely love 3D printing, if you guys didn't know, and I don't think I've been doing enough of it recently. And this was a really good excuse. It might be overkill, but damn is it satisfying. Ooh, yeah. Cherry flavored. It's spinning so much more smoothly now, but just to be sure I got all the cavities filled, I added in a little bit more grease and gave it one more pump. It was like a prolapsed anus. And with a little bit of cleanup, this thing looks brand new. I'm happy with this. So there are still bearings inside the wheels that I haven't repacked with grease, but I can't do that even if I wanted to because they are sealed units, meaning that whatever grease was put in from the factory is still contained within the bearing. So that means no contamination like there was on the other one. So they probably are okay to keep. They do run very smoothly and quietly, but they're probably factory original and 35 years old, so I probably should replace them. To install the wheel back on the bike, I added a bit of grease outside the bearing, threw on the sprocket damper, as well as the sprocket itself, and capped everything off with the greased up axle collar. And more grease and a collar went on the other side too. With the wheel now lined up, I lubed up the axle, oh yeah, lubed up the hole for good measure, and fully inserted the rod, which needed some persuasion. And after tightening everything down, the last thing to do is add the retainer clips back in. The wheel spins freely and very smoothly, and there's plenty of clearance between it and the fender liner. I was actually worried after pulling it back that it would be touching the wheel now, but no, we're good. I wanted to install the brake caliper back on next, but sadly the grooving on the rotor is beyond negligible. This is really bad. This is like a mountain range. Goodness gracious. Goodness gracious. The manual says the surface limit is 6 millimeters, so as long as the thickness is nowhere near that, it can absolutely be resurfaced. Fuck. Well, I guess it's a good thing I measured this off camera 2 months ago and already bought a replacement. I was smart enough to do that, but not smart enough to install it before I installed the wheel already. The replacement one is a used one, but it has super low miles, it's very smooth, and only cost me $16. Oh yeah, that is so much better. Ow, fudge knuckles. Going the right. And with the swap done now, I can reinstall that caliper. And now there's just one last thing to take care of for the back wheel. See, I actually did glue it down. Oh, I made that just very messy, huh? So earlier, when I mentioned that the evaporist was going to be used for something later on in the video, that would have been for this, the chain. But that's not gonna happen. One reason, I didn't realize when I bought the Evaporust that this was an O-ring chain, and not that you can't use Evaporust with O-rings, you totally can, it's safe. But the O-rings on this bike are just so destroyed. They're so far gone. So the chain as it is now is pretty much not safe to use. Not to mention that there's still not a retainer clip for the master link. If you were in some post-apocalyptic world where you need just anything to get you down the road, then yeah, use this chain. But because we're not, and I want a motorcycle that I can ride daily that's 100% safe and reliable, this ain't gonna cut it, chief. The logical next step would be to order a new length of chain, which according to the manual is a size 632, except, you know, they don't make this size chain anymore. From all my research, there's only new old stock available with O-rings that are also decades old, so no. I thought this was gonna put me in a bit of a pickle, but as it turns out, this is way smaller than the factory Sprocket should be. This is not the original Sprocket. And it's not the original 632 chain. See, chain sizes can be decoded very easily. The numbers are measured in eighths of an inch. So for a 632 chain, the 6 is for 6/8 of an inch, 3/4 if you reduce fractions, and that corresponds to the distance between the chain links. The second measurement is actually both of the remaining numbers with a decimal point between them, again in eighths of an inch, which comes out to 0.4 inches, and that is the inner width of the chain. With 3/4 of an inch set on the calipers, we can indeed see that that is the center to center distance of the links. But the inner width isn't 0.4 inches. It's not 3.2/8, but 3/8, 3.0, so this means it's a 630 chain. You know, I was wondering what these weird symbols on the side meant, but I guess at some point in the bike's history, someone did some proper maintenance and replaced the chain and sprocket set. And luckily, 630 chains are readily available from so many brands and suppliers. Unfortunately, I still gotta wait for a new one to come in, and that means you guys gotta wait for that too. But unfortunately, the rebuild parts for the anti-dive unit showed up, so how about we open up this guy and give him some love. As you guys saw, all of the disassembly for the main body was done by just removing some clips. But for the top unit, the section that connects to the front brakes, there's a proprietary retainer in here that's an internal hex with the hydraulic plunger sticking right through the middle of it. But that's no problem because a tool to remove this is something that you can easily make yourself. Just find a bolt of the same size and drill a little hole in the top. Beautiful. So now with two nuts tightened together and a little bit of leverage, this comes apart easily. And after some more cleaning, everything is ready for reassembly. The first thing going back in is the lower plunger. The control knob for that lower plunger has a variable profile, so depending on where it's rotated, the plunger will be either farther in or farther out, altering how restricted the passage for oil flow is. The easier the flow, the softer the suspension, and vice versa. The retainer plate for this was nothing but two tiny fragments when I took it off the bike, and I wanted to 3D print a replacement after modeling it up, but an OEM piece happened to fall into my lap, so I'm going to use that. The large spring and its cap were installed next, followed by the brand new plunger spring, and you can see just how worn out the original one was. It's a lot shorter. For the top plunger, the brand new O-ring and the square cut seal were lubed up and added in place, and the plunger was squeezed in. To retain the plunger in the plunger retainer, the tiny clip was added in place. Then to retain the retainer, I popped in a snap ring after pressing it into the bore. Oh, actually going up and down by itself. I wasn't doing that before I rebuilt it. And the cherry on top for this half of the system was the new steel-backed rubber cover. And then it's more of the same on the brake half. On this side, the plunger is pushed out when the front brake lever is pulled, and that plunger pushes down on the top plunger of the main body, and that going down almost completely blocks the flow of oil inside the unit, causing the suspension to barely compress. And that lack of compression during braking prevents the motorcycle from dipping forward and down as it otherwise would, hence the anti-dive name. With this back together now, it looks absolutely fantastic. Off camera, I've of course been overhauling the other fork and anti-dive unit as well. Most of it's been smooth sailing, no complaints, but I may or may not have absolutely rounded over the interior hex for the top of the system on this side. But it's not my fault, this thing is very stuck in there. So much so that after I rounded it over, I managed to get the tool firmly in there, but the tool sheared in half. Yeah. I made a new one, but this time soldered it to the plunger retainer to act as a strong but temporary way to hold it in place to prevent more rounding over. And I sheared the head right off the bolt. That head is now also completely stuck in there. At this point, I just wanted to cut my losses with this one, so I bought a complete used unit on eBay for not a whole lot of money. But it's not gonna work, at least not as is. See, the tops are unique to the left and right forks, with the brake lines exiting different directions, so the replacement should be the same as the broken one, not a mirror image. If only I specifically requested the correct one when ordering. Now, I could just buy a length of brake line and a flaring tool and custom make something that would accommodate the now different routing, but because I'm going to have to take the new one apart to replace the seals anyway, I could theoretically just take those good components from the new one and put them on the original body, given that I can actually get the mangled components out, of course. And I think I want to try that. So I cut some slots into it with an angle grinder, tried to remove it with the impact driver and absolutely failed to do so, doused the entire thing in penetrating fluid inside the ultrasonic cleaner, gave it hell with a heat gun, and many good thwacks with the impact driver, only to break the flathead bit. I was pretty pissed off at this point, as you can probably imagine. I only had one more trick up my sleeve, and that was welding another nut to the nut that's already stuck inside. Let's see if this works. Oh! Yes! I am quite pleased. Quite pleased indeed. Though I gotta give this little guy credit. It's amazing just how stuck it was. But the housing looks great, besides some burnt rubber still in there. So now, I can only hope that the replacement piece comes out just as easily. It also got the penetrating fluid bath and heat gun blast, just as before, and with the tool secured in place, and a little bit more penetrating fluid for good measure, we just cross our fingers. Let's do it. Let's do it. Oh, hell yeah. I love it when I don't absolutely ruin things, which is very rare. But with the bad parts trashed, good parts cleaned, and new seals here, this was rebuilt just as the other one was, and installed back on the forks, meaning this nightmare is finally over. But of course there's still the rest of the suspension to take care of, so let's finish up that nightmare too. Of course that would happen, why wouldn't that happen? The other fork was of course finished up too, so now with these done, it's time for them to go back on the bike and wrap up this front end. Alright, this is actually looking like a motorcycle again. It may have been 30 minutes since these forks came off the bike for you guys, but for me, it's been over 3 months. And there's still one last thing to do before I can ever think about them again. The reason the top of the fork tubes were so rusty when I first took them off the bike was because I don't have the caps that go over top of the forks to prevent all the water and other contaminants from getting inside. Now, had I not left the bike outside for a year and a half, that wouldn't have been too much of a problem. But that's okay, because it's fixed now, and I've got a solution for the no cap issue. But it's not this though, it's something else. What this is version 1 of my own DIY 3D printed replacement for the missing factory covers. I modeled this up in Fusion 360 and printed it off on JankBot. I designed the little tangs on the cap without any tolerances for the inner tube so that it would be a nice snug fit. But it's a little loose for my liking. Now, that is something that can absolutely be fine-tuned with more iterations, but at this point, I had a realization. What if I just attach the cap to the Schrader valve threads? Yeah, that'll absolutely work. So I printed up a little tube with the same thread pattern, and that's not bad. Next, I altered the original design to look something more like this right here, with threads in the middle of it, printed that off, and now this is perfect. It would only be more perfect if it was black and there were 2 of them. Kinda like these. They're very obviously 3D printed, layer lines showing and everything, but it's still kinda cool having something that I designed on here. And honestly, I was really proud of myself for coming up with this method of attachment, but as it turns out, I didn't. While looking online for an image of an OEM one to include in this video, I realized that's exactly how it was already done from the factory. It's kind of a bummer, learning that this is not an original idea, but on the other hand, it's pretty cool that it was a good enough idea to be implemented by Kawasaki. But alright, I wanted to end this video with everything done for the suspension and wheels, chain installed and the brakes fully bled, but I'm still waiting for that new chain to arrive, and it just hit me that I haven't replaced the original brake hoses. They might be okay to use, but this is one of those things that you probably just don't want to risk, with them being 35 years old. And plus, I'm sure there'll be plenty of you guys in the comments yelling at me to buy some stainless braided lines, so I'll shop around for those. So until next time, I'll see you guys later.